Hello, Mr. Betts here. This problem is a little bit more challenging using long division because we're dividing by an x squared term or an x squared expression. So let's just jump into it and see what that's going to look like. So off to the side, I'm going to do some side work here to do my long division. And just like with two terms, we look at the first term into the first term, we're going to do the same thing here. So x squared into 2x cubed is going to be 2x squared times. We multiply 2x squared. I'm sorry, that's going to be 2x times. We multiply 2x times that entire expression. So it's going to be 2x cubed plus 4x squared minus 30x. And we subtract. So 5x squared minus 4x squared is just x squared. Negative 27x plus 30x is plus 3x, and bring down the minus 14. Then x squared goes into x squared one time, so we got our plus 1. So we're going to have x squared plus 2x minus 15. And again, we subtract. 3x minus 2x is 1x. Negative 14 plus 15 is plus 1. So we get plus x plus 1 over x squared plus 2x minus 15. So that allows us to rewrite our integrand. And most of the integrand now is going to be pretty easy. So we have 2x plus 1. But then we also have that remainder part, the x plus 1 over x squared plus 2x minus 15. Now, this isn't immediately obvious, but with some practice with substitution, you might start noticing in expressions like this that if we let this be u, the derivative is going to be 2x plus 2, which is the same thing as 2 quantity x plus 1. And that x plus 1 up there is going to allow us to deal with that. So at this point, I'm going to use substitution. And I factored that 2x plus 2 right off the bat because I know I'm going to be canceling the x plus 1s. So this expression here, what I'm going to do is I'm going to go ahead and evaluate the antiderivative of the first two terms with respect to x. And for the last term, for this term, I'm going to rewrite that in terms of u. So this is going to equal x squared plus x plus the antiderivative of x plus 1 over u times du over 2 quantity x plus 1. So those x plus 1s are going away. That 2 can go out front. So we get 1 over u. So this is x squared plus x plus 1/2 natural log of the absolute value of u plus c. And then we do need to get rid of that u and rewrite that back in terms of x. So this is going to be x squared plus x plus 1/2 natural log of the absolute value x squared plus 2x minus 15 plus c. Now, this one only worked out because our remainder was in a very specific form where the numerator was a constant multiple of the derivative of the denominator. If that hadn't happened, we wouldn't have been able to do this. So if you're going to be expected to be able to evaluate an antiderivative, something along those lines would have had to happen in order to do this. If we didn't have an x in our remainder, but we did have the 1, then we've seen completing the square. So completing the square might be an option for the denominator to rewrite there. So depending on what the form looks like after the long division, we may have to do a variety of different things to complete the antidifferentiation.